for AGS 1, graphing linear inequalities. So right now, as far as we know, Zoom is having some issues, so this is the video I want you guys to watch where we're going to go over the lesson. Okay? So the first thing we're going to look at is the vocabulary for linear inequalities. How do linear inequalities differ from linear equations? The first thing you guys should notice is it's very similar to another form we are familiar with, and that's slope-intercept form. Slope-intercept form is y equals mx plus b, where we see this is our slope. So our slope here is negative 3 over 1, and our y-intercept is the constant, and its location would be at 0, 4. The only thing that differs in how the numbers and the inequality looks is this is an inequality symbol instead of an equal sign. So inequality symbol instead of an equal sign. That indicates there is going to be an unlimited number of solutions in this case. Okay, so I know when I went over this with my period 1 and period 3, we had a little bit of trouble with the idea of a solution space or solution set. So we're going to talk about a linear equation. We're going to go back a little bit and discuss what solutions to linear equations look like. We're used to graphing linear equations like this one, 2x minus 4. But sometimes when asked, what's the solution to a linear equation, we're not sure what that means. So the solution to a linear equation is any point on the line. Any point on the line. So if we take any point on the line and we substitute it into our equation, we'll see that the equation is true. So the first point I'm going to try is 3, 2. So 3, 2, when I sub it into the equation, y equals 2x minus 4, I should get both sides to be the same. So my y value is 2, my x value is 3, and when I simplify this, I get 6 minus 4, so 2 equals 2. That means this point solves that linear equation. Okay, well maybe we got lucky. Let's try another point. 0, negative 4. Alright, we'll try it again. 0, negative 4. Saying negative 4 should equal 2 times 0 minus 4. Negative 4 equals negative 4. Okay, well that's also true. Let's try a different point. How about 2, 0? Okay, so if we're going to do 2, 0, we get 0 should equal 2 times 2, take away 4. 0 is 4 minus 4. That's also correct. We could use any point in between the nice lattice points as well, but for a linear equation, the solution would be any coordinate pair on the line itself. For a linear inequality, our solutions look a little bit different. They actually look like half planes. So any point in the shaded half plane here is a solution to this linear inequality. And the shaded half plane, if this line extends, well it does, the line extends, our shaded half plane would also extend with it. So everything on this side of that line would be part of our solution set. So it keeps going. That's why we call it half a plane, because it's half of the coordinate plane. The line that's cutting the plane into two is called a boundary line, and it separates it into a lower and an upper section. In this image, it kind of looks like a left and a right, but we refer to them as a lower and an upper. So test points are points that we pick, any coordinate point in their shaded region, we choose it, and we see if it does indeed satisfy our inequality. So I've chosen the point 3, 2. And I want to test it in this inequality. So I'll substitute it in and see if the inequality is true. Negative 3 times 3 plus 4, so 2 should be greater than or equal to negative 9 plus 4. 2 is greater than or equal to negative 5. That's true. Any other point we chose in this area, so if I chose like 1, 5, should also work. 5 greater than or equal to negative 3 times 1 plus 4. 5 is greater than or equal to 1. That's true. If you pick a point that's not in the shaded region, let's say I pick negative 2, negative 1, when I substitute that in, I would see that my inequality is not true. So negative 1 greater than or equal to 6 plus 4. Negative 1 is not greater than 10. So this is not part of the solution set. The shaded area is our solution set to our inequality. When you're graphing a boundary line, if the line is solid, any point on the line is part of the solution. If the line is dashed, you do not include the points on the line as part of your solution. Okay, so how do we determine what type of boundary to use when we're graphing linear inequalities? So we have 4 images in front of us, and if we look at the boundary line, we see that the first one is dashed, the second one is solid, the third one is dashed, and the fourth one is solid. So we're looking for something that is the same between the 2 with the dashed and then the 2 with the solid. So if I look at the dashed one, I see y is greater than negative x minus 5, and I see y is less than 7/3 x plus 2. So it doesn't seem that the direction of the inequality matters, but we have a greater than or a less than. For the solid line, I have less than or equal, and I have greater than or equal. So for a solid line, we have the equal sign underneath our inequality symbol. So here we know that the boundary is not part of the solution. It's like an open circle in the inequalities we were graphing last module. And here, when it's a solid line, the boundary line is part of the solution. So any points on the line also are part of the solution. Okay, so if we've got less than or greater than, we use a dashed line. If we got less than or equal or greater than or equal, we're going to use a solid line. I think I read those backwards, but this one's greater than. This is greater than or equal. All right. Okay, great. Well, we figured out how to graph the boundary line, or like what the boundary line should look like, but how do we determine which side is our half plane that needs to get shaded? So if the inequality is in slope-intercept form, so if we see y is like greater than, less than, whatever, mx plus b, the important part that is solved out for y, we can use this tool. We always want to rely on test points to make sure we're correct, especially whenever our inequality is not in this form. So what you do is you put your pin on the line, the boundary line, and I'm looking at this one and I see everything is shaded above that boundary line. And the next one, if I put my pencil there and I shade, everything would be below. The next one, everything is also below. And in this one, everything is shaded above. So when we shade above, we need to find something in common between the ones that had above and when we shade below. So for above, I see my two equations where y is greater than negative x minus 5 and y is greater than or equal to 7/4 x plus 2. So our two formats are y is greater than mx plus b or y is greater than or equal to mx plus b. So really the greater than part of this tells us to shade above. For below, we see y is less than mx plus b or y is less than or equal to mx plus b. So here we're looking for the words greater than. We can have the or equal to as well. And here we're looking for less than. I can't stress enough, it has to be in slope-intercept form or solved for y in order to use this rule. If it's not, you need to rely on a test point. Okay, so we know how to determine the boundary type, and now we know a method to determine which way to shade. Let's go ahead and try one. We're going to graph the inequality y is less than or equal to negative 2x plus 5. So we need to decide whether it'll be dashed or solid. this one is going to be solid because it has the or equal to part. So we will do a solid line because it has the or equal to. Since we use that for less equal or greater equal. We've got a y-intercept of 5, and we've got a slope of -2. Let's make it -2/1. So I'm going to graph my slope now that I've got my y-intercept. And it's a solid line, so I'm going to draw a line through it. Okay, so we've graphed the boundary line. We decided it was solid. We know the boundary line in this case is part of the solution, so I'm going to just mark that boundary is part of the solution because it's a solid line. Okay, so now we need to determine which direction to shade. We have a y is less than or equal to, so we're going to shade below. So if I'm looking at this with my pen, I would go down and I would see that that would be this side. Now we don't just stop like where we see below, but it's everything that got cut. The plane got cut into 2 pieces, and so once we figure out the side, we shade everything on that side. Okay, it says use a test point. So pick a point from the shaded region. I'm going to pick the point -2, -1. Oops, sorry. My hand keeps moving apparently. -2, -1. So negative, remember your inequality is y is less than or equal to -2x plus 5. -1 is less than or equal to -2 times -2 plus 5. -1 is less than or equal to 4 plus 5. -1 is definitely less than or equal to 9. So it works. If we wanted to pick a test point that didn't work, we could pick the point like 3, 4. 4 would be less than or equal to -2 times 3 plus 5. 4 is not less than or equal to -1. So that point does not work. So it's not part of our solution set because it's not in the shaded half plane. So any point in the shaded half plane and the solid line are our solutions to this inequality. Okay, we'll do another inequality here. We've got y is greater than -2/3 x plus 1. We are going to use a dashed line because we have a greater than or a less than. So a dashed line is used for greater or less. And we have a y-intercept of 1, and we have a slope of -2/3. So I'll go down to right by 3, down to right by 3, up to left by 3, up to left by 3. Since it's a dashed line, we're just going to dash in between those points. And the boundary line is not part of the solution. So boundary is not part of the solution. Because it's a dashed line. Okay, we've graphed the boundary line, we've decided now which side to shade. We've got y is greater than, so we are going to shade above. So take my line, I go up, so everything, let me do that a little bit better. Everything above is going to be shaded. I'm trying not to include that line just to make a point. So everything above that boundary line, the half plane above it, is our solution set. Any coordinate points in that set are a solution to this inequality. So I'll pick a test point 2, 3. So So I have y is greater than negative 2/3 x plus 1. So if I'm picking 2, 3, I'm saying 3 is greater than or equal to negative 2/3 times 2 plus 1. 3 is greater than negative 4/3 plus 1. 3 is greater than negative 1/3, which is true. Let's pick another test point just so you guys have multiples to choose from. Let's pick like 6, 1, because it's also in the shaded region. We are saying 1 should be greater than negative 2/3 times 6 plus 1. 1 should be greater than 2/3 of 6 is 4, so that's going to be negative 4 plus 1. 1 is greater than negative 3, which is true. So any point in that shaded region is part of your solution set. Your boundary line is not part of your solution because it is dashed, and any point in the non-shaded area is not part of your solution set. Make sure to watch the extra videos we've posted on Canvas for additional help, or come to our office hours and ask us directly.